Just a sec. I've updated my Mac since we've done this, so I have to go in and system preferences and let it screen share. No. Okay. I am going to have to reboot real quick or restart Teams.
Okay.
Speaking of Mac, so while we're waiting, when is the M1 chip going to be in the MacBook Pro 16? Does anybody know?
I've not heard timelines on the M1 stuff.
And when is Microsoft going to put the Go ARM architecture on all their stuff?
Wish I could tell you.
Okay, I'm back.
Hey, Alec.
You're still frozen, Alec. Can you hear me?
I can hear you.
Okay.
I'm frozen.
You are on my screen. I don't know if that's applying to everybody.
Yeah, you're frozen on mine.
Well, shoot. All right. I guess I'll just kill my video and we can continue on from here.
Okay.
So welcome everybody to our next Iowa Microsoft Azure User Group meeting. Kick things off with, we're doing a lot of our scheduling on our meetup page. Here's some of our other handles. If anybody you know couldn't make it to the meeting today, or if you want to be notified of future events, feel free to follow us on our YouTube or Twitter. And if you have any questions, concerns, future topic requests, anything like that, feel free to email any of us and we can hopefully pass it around or figure out who's the best person to help you out. Our schedule for today is going to be using Cosmos DB to build global scalable NoSQL applications, and that'll be presented by Tonio. And then right now, we do have an opening for our next slot. If anybody would like to give a presentation or has any topic they want to hear about, feel free to let us know. And we can work with you to figure out a topic or get you into that time slot. And with that, I'm going to pass it over to Cody for today's sponsor of P3.
Hey, everybody. Good afternoon. My name is Cody Coors. I'm with Professional Project Partners. We're an IT recruiting and staffing company headquartered here in West Des Moines. We offer different IT consulting services, direct placement opportunities for different companies and individuals here in the Des Moines area. Focus really on anything IT related within the software delivery lifecycle, from project management, program management, software development opportunities to data warehouse, business intelligence roles as well. Majority of the opportunities and network that we work within is focused here in the Des Moines area. I would say about 90% of the work that we do is here focused locally in Des Moines. We do have a presence nationwide as well through Minneapolis, Madison, some clients in Phoenix, Arizona. So yeah, that's really about it. If anybody has any questions about the job market, kind of what we've been seeing, or just interested in hearing about new opportunities, feel free to reach out to myself here and be more than happy to let you know what's going on here in the area. But we'll do a raffle at the end for a $50 gift card for Amazon, and then some P3 swag as well. So we want to thank everybody Alec for giving us this opportunity to sponsor the event. We really appreciate it and can't wait to continue to be involved.
Yeah, thanks for being a sponsor, Cody. Be our third sponsored event, second sponsor. So that's pretty awesome. Thanks to P3. With that, I'm going to introduce our speaker, Tonio. Tonio is a principal cloud solution architect at Microsoft. He's been in IT industry for over 20 years. During time, he has worked on numerous companies building large applications, data warehouses, data lakes, and comprehensive analytics solution. Most recently, he's been working to help companies with their cloud architecture with a focus on architecting analytics solutions in Azure. He's also a lecturer for the Master of Business Analytics program at Iowa State Debbie and Jerry Ivy College of Business. With that, I will pass it over to you, Tonio.
Thank you very much, guys, and thank you for the invitation. Hopefully you can all hear me well. Let me share my screen here. Excellent. Okay, so good afternoon, everyone. I'm here to talk about Cosmos DB, right, and how to use it to build these high scalable, global distributed modern applications. And if you know something about Cosmos DB, it's a NoSQL database, right? And it's a cloud-based NoSQL database. Now, I found this article recently. My hope is that by the end of this talk, you will understand why when Walmart decided to design their cloud native application architecture, wanted to make sure it was high quality, elastic, cost effective, highly available, and of course, high performant. They decided to move away from traditional relational database management systems with hundreds of tables and scalability issues, and instead decided to use Azure Cosmos DB with a schema-less design. And this provided them with the availability, scalability, and the less than 10 millisecond response times that their modern e-commerce platform needed. Right. One thing I'll say up front, if you guys have any questions or comments, you want me to go deeper into any of the topics, please unmute because I cannot see the chat right now. So just unmute and ask me any questions, okay?
I'll monitor the chat for you, Tonio.
Oh, thank you very much. Thank you. Let me step back a little bit and provide some historical context, right? Because some of you may be familiar with NoSQL databases, some may not. Okay. So I would say modern applications like the e-commerce application that Walmart was building have very different needs. Right? These are not your traditional data entry apps where the scheme is well known. And it doesn't change often, right? The schema doesn't change often. These modern applications need to process very large amounts of data really fast, right? They also need to offer a very low latency to users, regardless of where they are around the world, right? And they usually do that by providing the distributed copies that are closer to the user. Right? If you think about an application that you're using on your web browser, it is highly unlikely you're going to wait more than, I don't know, 30 seconds for that page to refresh, right? We have very, very low tolerance to high latencies. That means, for example, if you're a user that's in Brazil, and you should probably read and write data from a database that's hosted in a Brazilian data center to reduce that latency. Okay, those are some of the challenges in modern apps. As a result of those new modern application requirements, NoSQL databases emerge, right? They've increasingly supplanted relational databases in many modern application environments. And these NoSQL databases emphasize non-relational data storage, right? In other words, rather than storing the data in rigidly structured table design, right, we have tables and columns and relationships. NoSQL uses any number of methods, right? Or in some cases, a combination of methods to store data in a way that's decentralized and without enforcing a strict schema compared to relational databases. Now, with those challenges in mind, with the emergence of NoSQL databases, and I would say highly influenced by the work of Dr. Leslie Lamport, Turing Award winner and world-renowned computer scientist, Microsoft created Azure Cosmos DB. Right, it is a platform as a service, right? It's cloud native, right, and was built from the ground up, run on Azure, right? So there is, for example, no native way to run Azure Cosmos DB outside Azure. It is what we call an Azure Ring 0 service, and thus is available in every Azure region that we deploy. Okay, so you don't have to worry about the service not being available in specific geographies. It is a NoSQL database, so it's unlike the relational databases of the world where you're dealing with tables that contain rows and columns of data with relationships between them. Instead, Cosmos DB offers several data models, right, including key value for simplistic data stores, right? Column families, right? If you're familiar with Cassandra, it'll be similar to that. Document, similar to what MongoDB will do, and graph, right? Like your Neo4js, for example, with a bunch of APIs to build your application on top. So it's a NoSQL database that's polyglot, right? It speaks different languages. It stores the data in many different formats to accommodate the needs of your application. Okay. Now let me, as I mentioned, there are many capabilities. This slide is slightly busy, so let me briefly go through some of them, right? The ones I figure are more relevant, that we can spend the entire day just talking about Cosmos and its features. As I do that, I'll be jumping to the Azure portal, so you can see how easy it is to enable these powerful capabilities. And again, at any point as I go through this, if you have questions, please do stop and ask. I'll do my best to answer, and if I don't have an answer, I'll get back to you. So the first and most important capability is security, right? This is the first thing we think about when we're designing our applications. Cosmos DB provides you with the comfort of the trusted Azure platform, right? We do have some comprehensive compliance certifications, which includes ISO 27001, ISO 27018, HIPAA, PCI, SOC 1 and 2, FedRAMP, and others, right? We also provide data encryption, both at rest and on the network, right? And this encryption includes the data, the index, and the backups, right? Most importantly, this is completely transparent to your application, right? And has no impact on performance, throughput, or availability. Our SLAs have already baked in the time that it takes for us to encrypt and decrypt the data as you work with it. And of course, we also have additional layer of security intelligence provided by Azure Threat Protection, right? Like many of our older data services in Azure. The next feature is latency, right? And we talk about how we want our application to be responsive, right? Cosmos DB is the only service in Azure that provides a financially backed guarantee that latency from a point read or write will always complete in less than 10 milliseconds at the 99th percentile, right? So if you want something that, is really fast, less than 10 milliseconds is what we can guarantee. And if we don't fulfill that, we'll pay you back for those requests. And as you can imagine, this supports the development of blazing fast applications that really guarantee this latency at any scale, right? So it doesn't matter if it's a small database, if it's a very large database, or if it's a database that has many copies distributed around the world, right? This latency is guaranteed. But latency is not the only SLA that we guarantee. Azure Cosmos DB is also the only cloud service that provides money-back SLAs on high availability, throughput, and consistency. Okay. Best of all, you can monitor all these SLAs directly from the portal. So make it very clear to you, this is what you're getting with the service, and these are the current service levels, I guess, compared to the target. I'll show you that when we jump to the portal. Now, because of this, you can architect your application and configure Cosmos DB to achieve these 5 nines of availability, which is pretty hard to achieve on any architecture design, as you guys may know. Now, in the world of NoSQL, there is this thing called consistency models, right? In the relational database, you're very familiar with what we call a single consistency model or strong consistency model, where everything you write has to be completely replicated for the transaction to be closed, right? You get an acknowledge that the transaction is complete, and then everyone who reads that data will read the latest data that's been written, right? For that, traditional relational databases rely on locks, so sort of locking or versioning mechanisms on the data. NoSQL databases avoid that, right? They sacrifice that consistency to provide better availability on the data. That means that if you have one user writing to the data and another user trying to read that data, we prefer you to read maybe an older version of the data as opposed to being waiting for the initial transaction to complete. Okay. Now, the great thing is that Cosmos DB supports different consistency models, right? It doesn't force you into making a choice between the extremes of strong consistency, like in the relational database world, or eventual consistency. Okay. Instead, it allows you to choose what is appropriate for your application, right? As you can see on the slide, we have 5 different type of consistencies that you can choose, right? Where session consistency is the one that's more widely used by most applications in Azure. And this means that within the session, the reads and the writes are monotonic, right? This is referred as a read your writes or write follows reads. This provides predictable consistency for that specific session, right? And if you think about a traditional e-commerce application, I may want that type of consistency for my shopping cart, right? No one else on the world using that e-commerce site is going to look at my shopping cart most likely, right? So the consistency is important only at the session level there. Now, one thing that's pretty cool about Cosmos DB is that you can set up this consistency level at the entire database, but then depending on the scenario in your code, you can relax that consistency. Okay, so you may maybe set a session consistency model for the entire database, but if you are maybe doing reads, very heavy reads, and you don't care too much about reading the latest version of the data, you may move it to eventual consistency. Okay, on your code. Now, let me go to the Azure portal so I can show you some of these things I've been talking about. Okay, let me find some good Cosmos DB database where I can show you that. Okay, so this is Azure portal. Hopefully you guys are all familiar with this. I've just searched for one of my Cosmos DB databases, right? And from here, you can see if I go to the metrics side, you can see where this database is replicated, right? The main initial database was created here in the central US, and you can see that's been distributed to other places in the world to reduce this latency I was referring to, right? From here, you can explore things like throughput. Right now, this database is not being utilized, so otherwise you will see actual the number of requests and different responses that they have, okay? Storage, right, in terms of data and index, so we will let you monitor that. The availability, right, what we offer and what's the SLA. So right now it's 100% available, and this is the SLA that we provide. The same for latency, okay. Consistency, and this applies, of course, to databases that are replicated. Otherwise, there is no chance for you to lack consistency, right? If it's not database has been replicated. So this is a place where you can actually look at the different SLAs that we offer. Another thing that I mentioned was consistency levels. So let me having the portal a nice way to look at consistency. Okay, let me. There we go. Okay. So as you can see, I have my database here, and if I point to another region here on the map, I see what is the latency between the replication. Should probably zoom this. Let me refresh the browser because it's not displaying the bottom part, which is where you can actually see the latency being displayed. Okay, so it looks like to replicate the data from Central US to Brazil, it will take 150 milliseconds, right? And as you design your replication strategy, this is something that can help you decide where should I move your database, right? To West Europe, it will take 125 milliseconds. So that is one aspect of replication, just to understand latency, right? So right now is in Central US. If I wanted to replicate this to West Central US, it will be 15 milliseconds, right? Makes sense. They are geographically closer. Now let me zoom in here. These are the consistency levels I mentioned, right? Let me switch to eventual consistency and show you on this analogy here how it will work, right? Here we have 4 different sessions in different locations, right? You have Central US writes. This is the one that's doing all the writing. And we have 3 readers here in Central US, Australia Central, and East Asia. And as you can see, as we write data, the other readers will read the data and it will eventually, they will eventually all read the latest version, right? This is what we call eventual consistency. There are no guarantees on when you will read the data or if you may read the data, the same record out of order. Okay, so this is the one that provides, I would say, the least guarantees, what we call eventual consistency. Now, we can also look at strong consistency, and this is what databases do, traditional relational databases. As you can see, all the readers follow the writes, right? They all get the same version of the data at the exact same time. And then we have session, which is the most widely used, and I'll select it right now. And you can see that Central US here writes and reads, they are using session A. This third one here is in Australia Central, but it's also in the same session, right? It's sharing the same session token. And there are techniques for you to share the same session with applications that are running on the other side of the world. And the last one is actually on a different session. It's session B. Okay. And you can see how the first 3, because they are on the same session, they all follow along. But for the last session, eventual consistency happened. Okay, because it's not on the same session. It's not on session A as the first 3 applications. Okay, so this could be the case in which you've defined the consistency model as session at the database level, but then you've relaxed it as eventual on the other application that's running on East Asia. Okay, so let me jump back to the presentation. Perfect. I know consistency model, if you haven't worked with NoSQL databases, may be something slightly difficult to you know, understand at the beginning, but as soon as you start trying this, it becomes really really easy. And I think this this nice simulation we have in the portal and the documentation we have helps you really as you go through the decisions of choosing the right consistency model for your application. Now let's jump to a different topic here. Let me close this. Azure Cosmos DB, through its scale-out model, provides limitless scale, right? Both in terms of throughput as well as storage. This helps you support apps of any size. And if you think about it, this allows your application to grow to accommodate peak demands and to shrink when demand is not needed, right? And giving you a great way to manage costs, right? You don't have to pre-provision any resources in advance, right? You can adjust the resources behind your database depending on what exactly you're going to use. And the beauty of it, because you've probably heard about other databases that can scale up and down, the beauty of it is that there is absolutely no downtime, right? This is built for an OLTP always on environment. So all this scaling happen with no downtime. Now to go deeper on the scalability in Cosmos DB, I need to introduce the concept of request units, or RUs for short. Right, a request unit is a performance currency that abstracts the system resources such as CPU, IOPS, memory that are required to perform the database operation supported by Azure, right? In this case, supported by Azure Cosmos DB. And the idea is that when you define what database you want, instead of thinking I want 8 cores and I want, I don't know, half a terabyte on each core or on each node, and I want this specific number of IOPS, I just define RUs. This is the number of RUs I want, and you define it RUs per second. That's how you define it. And that's it. We'll manage all the internals and provision all the compute to accommodate the SLAs that the number of RUs you've defined will guarantee, okay? Just to give you a sense, right, to make it less abstract, you can consider that one RU as the resources necessary to read one K document. Okay. A write operation may use 5 RUs, right? Write operation of 1K document will use 5 RUs. One read may use 1 RU. Remember, you're gonna pay for these RUs. That's how you pay to Cosmos DB, right? So if you know that 1 RU is what you're going to consume on each read of 1K document, and you have 1,000 reads per second, right? Let's say your application requires 1,000 reads per second. You know that you need to provision at least 1,000 RUs on your database. That's how easy it is. Okay. Now, the consistency model also affects the number of RUs needed to perform these operations, right? The stronger the consistency model, the more RUs you may require, right? If you think about it goes to consensus, right? When you have data that's replicated around the world, and if you read and you want a strong consistency, you need to read all the copies and make sure that all the copies agree before you return the result. And that requires more RUs. Now, there are 3 main ways to allocate RUs to Cosmos DB collections. These are very important, right? When you develop your application, you have to understand the patterns of your application. So you allocate, use the best model to basically guarantee the latency that you need and the throughput that you need, and also save on costs. The first way, the first model is what we call the provision model. Right here, we manually or programmatically or through the portal, we specify the RUs needed by your application. Right. On this example, if you look at the screen, we've provisioned a container with 5,000 RUs per second, represented by that blue line. And we can see that all the workload, represented by that black line, requires less than 5,000 RUs over time. Right. So we're good here. We're good. On this model, if at any point our application requires more than 5,000 RUs, the request is throttled, right? And the Cosmos DB client will automatically retry a specific number of times after waiting a small period of time. That is all handled by the API. Okay, so the service will reply. If you've been throttled, the service will reply with the amount of time the client needs to wait, and basically will automatically retry for you. So you don't have to worry about that programming that on your code. And that, that looks okay, right? This model works great, but what do we do when our application doesn't need all 5,000 RUs, right? Maybe, let's say maybe at night when there is less people ordering products, right? What do we do? What do we do if we need to decrease that number of RUs? And well, that is fairly easy, right? You can monitor the Cosmos DB utilization metrics and use an Azure function to programmatically reduce or increase right? The number of RUs allocated to the collection. Right here, you can see on the diagram that we have a window of time where we only need half of the RUs. So we have a function that makes that change, lowers the number of RUs to half. It runs some up to a point, and then it increases that number back up to 5,000. By doing this, we will let customers manage costs, right? Because you only get paid by the RUs you provision, right? And this is all great, right? Just keep in mind that the example shows just one change here, right? One change down, one change up, but you can, through functions, you can programmatically do this at any point, right? You can go to the portal and manually update this value, or you can programmatically do this. There are no restrictions on how often you increase or decrease these numbers, okay? And it's still a process that you have to code and manage, right? So, and if you look at our workload here, it's relatively predictable, right? You have very good use maybe during the day. At night, it drops to half, and then the next day it goes back up to 5,000. That's very predictable. What happens when you have more irregular, or let's say even unpredictable workloads, right? What do we do there? Well, for those scenarios, Cosmos DB offers you the AUTOSCALE throughput model, right? Here, what you do is you set the maximum RU that's needed for your workload, like ever, right? And Cosmos DB will automatically adjust the RU value based on what you need at that specific time, right? So you can see how the number of RUs dynamically changes based on your needs, how that blue line follows your workloads, right? And the oscillation will be from the maximum value that you set up, the minimum value, which is 10% of that maximum value, okay? And of course, you can always increase or decrease the maximum value here. So even though you have AUTOSCALE, you have to decide, okay, my maximum is 5,000 RUs, but doesn't lock you into that value, right? You could still use Azure functions to maybe during some points in time increase that maximum, right? Because you know that peak is going to go really high. Or maybe your pattern is unpredictable at night, but still it will always be below 3,000 RUs. So with Azure functions, you can move this maximum back.
Hey, Antonio, we have one question in the chat. Is there additional cost for the AUTOSCALE model?
Yes. So the AUTOSCALE model, the RUs that you pay for AUTOSCALE model are more expensive than you pay for a throughput, for a traditional provision model, right? And if you think about it, kind of makes sense, because on the back end, the way we do it is we have some compute that's rarely available. It helps. Remember, when this thing scales, you don't notice, your application doesn't go down at any point. Okay, so it is slightly more expensive. I think if you do have an irregular workload, that the one I'm listing on this chart, right, the one you can see, then you end up paying less overall, right? As opposed to having a 5,000 provision over the life of your collection. And I've seen customers that are getting super sophisticated, right? So they know this one follows really well, and they use a combination of AUTOSCALE and Azure functions to lower the maximum or increasing the maximum as they need to. So I would say we're giving you different models. It'll be up to you to look which one is better for your workload, which one you're willing to pay for that, right? Okay, so let's keep moving. So I've showed you two scenarios, right? But you are thinking already, right? There are situations where we really don't need all these awesome latency or throughput SLAs, right? That Cosmos DB offers you. Maybe we're doing development, or we're doing some testing that's not doesn't require that, right? And for those scenarios, we're coming up with what we call a serverless model, right? Where here you pay per request, right? So in the previous two scenarios, you're paying by whatever it is you've provisioned, or it's provisioned at that specific time, right? But on this, you have your database and you develop your application, and every time you submit a request for testing, see if it's working or not, you pay for that, right? So this is really the I would say less the least expensive way to run Cosmos DB on Azure. Of course, it's still coming soon. There's some private preview, but it'll be available pretty soon. So let me summarize, right? These are the 3 ways to provision throughput, and it all depends on 2 things, right? Is how predictable is your workload, and if you're willing to pay for the SLAs that are required, right? If your application has a strong SLA requirements for latency, for example, and your workload is very predictable, go with the provision throughput, right? Now that will be your best bet, easier to manage. You still have a chance to automate moving those RUs back, okay? The up and down as you need it. We have pretty awesome integration with Azure Monitor, so you can actually see when, at what points during the day, maybe your requests get throttled, right? And by analyzing those patterns over maybe a period of a couple of days, you will start learning, when is acceptable to decrease or increase the number of RUs, and with the purpose of making sure you guys manage costs properly, right? We want you to have the best experience in terms on your app and also manage cost. If your workload is not that predictable, like the one that's in the middle here, in the middle right, then AUTOSCALE is probably your best bet, right? The RU unit cost may be a little higher, but because you are not provisioning the maximum value, right, and you are really following whatever it is that you need, you may end up paying less. And this is something, again, you can test, right? It's a good thing. Just go test. It doesn't work, you'll go back to standard. And then we have serverless that's coming. Remember, this it'll be available soon. This is more for development, test scenarios, or who knows, maybe there are applications that don't have these crazy SLAs, right? Maybe this is something that we use on premises for, I don't know, something that's not mission critical, right? You can still use a very good NoSQL database and pay way less because the guarantees that exist in the other 2 models don't apply here. Now let's go to the portal and look at those numbers. 1 second. Okay, so let me go to Data Explorer here. Bigger. Okay, so as you can see, I'm using the SQL API. Remember, Cosmos DB has many APIs, right? I'm working with the SQL API. It's a little of a misleading name. It's really the core API, and it's using a document. But since you can run SQL on top of that, has that name, okay? Here I have a single database called AdventureWorks. I have 2 different containers, right? And each container, of course, has some items. And if we look at the items, these are documents, right? And as you would expect, these documents, in this case, these are sales orders with the details of the orders, right? So the product that was ordered, I guess, and the different products and different quantities. Now, this in the relational world, this is a no-no, right? You have a hierarchical data structure here. In the relational world, you'll have a header and a detail, and they are all related in a one-to-many relationship, right? With the appropriate cardinality. In the NoSQL world, you compromise, right? You try to pre-join things as to speed up the retrieval time. Okay, so that's what we have here in sales orders. Let me create a container so you can see some of the options we were talking about. So I'm gonna do new container. Okay. The first, it tells me, do you want a new database or an existing database? I'm just gonna use existing database. You enter the name of the container, the partition key. Okay. So /ID. A partition key, like in traditional MPP environments, is more of a routing mechanism, right? Remember, your data is going to be charted, right? It's going to be partitioned, horizontally partitioned across many units of compute, and this is the routing mechanism, right? The ID is hash using the Marmor3 algorithm, and that is what we use for the hashing. Analytical store, I'll cover this later. And that's it, right? So let me see. It's a new, let me create the database level so I can show you some of the throughput options I've been talking about. So this is a new database. When you provision RUs, you have two options. You can provision the RUs at the entire database level or at the collection or container level, right? AdventureWorks has the RU provision at the entire database level. That means that the other two containers, they share the RUs. That's typical when these two containers actually are part of the same application, right? So your application requires the latency for both together because the way it reads those containers, right? Or the items on those containers. So you allocate the RUs at the database level. In my case, I'm going to create a new database. I'm going to provision the throughput or the RUs at the container level. And this is where you set up if you want a manual or the provision model or the AUTOSCALE model. Okay. And it tells you exactly what is the AUTOSCALE, how it works, and how much you're going to pay for it. So you get a pretty good sense from the beginning on how much you pay for it and the RUs allocated to it. Let me show you one that has already been created. Oh, sorry. So this one, for example, has manual 400 RUs at the database level. And let's say I've been using this application for one store, and now we're onboarding 9 more stores. So I need to scale this up. So I'm just gonna hit 0, and it's gonna go from 400 to 4,000. And the only thing I need to do is save now. Okay. Now, remember, this database is replicated across the world. It has like 6 different replicas in India and Australia. You saw all those on the map. So you have to be mindful of the cost, right? As I go from 400, which is $116 per month, to 4,000, you are also increasing your cost. So the good thing is that it's a very easy relationship between our use and cost, right? So it's something easy for you guys to handle. If I click save here, let me change this. The RUs will be updated on the back end, right? That's so without us having to make any changes, really. Now, if you are just designing a new application, right? Let's say you are designing this application and you want to understand what is the RU require, right? One thing that you could do is prototype a sample document and then try to run some queries, because we're going to tell you exactly the number of RUs that are used in the query, right? So we're going to do that here. I'm going to type a new SQL query. I just copy paste the data from that document. Let's see, sales order ID. And I executed that query. As you can see, the scaling probably still happening, right? You can see here, well, it's not showing anymore. Oh, it apparently has finished with the scaling. It didn't restart or didn't kill my session or anything. But what I wanted to show you is, okay, so I ran this query and it brought the document that I was looking at. This is the document. But here I have what we call query stats. And this tells me exactly number of RUs that were used on reading that document. Okay, so reading a document of that size for a database that's replicated 6 times around the world on that consistency model is going to cost me 3.12 RUs. And maybe I'm very familiar with the type of or the frequency of this type of operations on my application. Let's say 10,000 of these, so I can quickly determine the number of RUs that my container or my database is going to need. Okay, so with this we help you eliminate all the guessing out of sizing your database. Not that it's something that you cannot change at any time, but if you want to get it really close to right from the beginning, you can do this. Okay, so let's jump to the presentation again. Okay, so remember these applications we're talking about, today's applications, right, are required to be highly responsive and always online, right? And to achieve this low latency and high availability, instances of these applications need to be deployed in data centers that are close to their users. We talk about the example of the Brazilian user running their app that's very close or deploying a Brazilian data center. And if we want low latency, these globally distributed applications need a globally distributed database that can transparently replicate the data anywhere in the world to enable these applications to operate on a copy of the data that's close to its users, right? And in the ideal world, you want to just flip a switch on the database and it will do all this replication for you, and it will allow for you to have a master, multi-master scenario without you having to do anything crazy on your database. It will automatically deal with data conflicts or give you a couple of options to deal with data conflicts. And that's what Cosmos DB does for you, right? And remember, best of all, you don't have to worry about this synchronization of copies or dealing with multi-write merge conflicts. We do that for you, okay? So let me show you an example, and some of you may have seen this slide, right? Here you have an application running on the US West Coast, while the Cosmos DB database is located in Southeast Asia. Right, somewhere in Southeast Asia. Right, as you can see from the logs, before I switch, as you can see from the logs in that red box, the latency, the read latency is about, I don't know, 178 milliseconds, right? So it's just not bad, right? But maybe completely unacceptable for some applications, right? So how do we reduce that latency? The easiest way, the simplest way, will be to replicate the Cosmos DB to the US West region, right? That way, we immediately reduce the latency of your application to about 5 milliseconds, right? This is a 97% reduction, but just by switching where your application is automatically replicated, okay? And best of all, I think, is by using the Azure Cosmos DB multi-homing APIs, your application is aware of the nearest region, right? And can send requests to that region, right? And the nearest region is identified without any configuration changes on your app side. And as you add and remove regions, your application doesn't need to be redeployed or paused, right? It continues to be highly available at all times. Now, multi-homing APIs are awesome, but there may be some situations where, based on some weird business rules, you may need to overwrite the default location that the multi-homing API gives you. And you can easily do that, right? By injecting the code in your code, right? What is the, I would say, the preferences on the regions that you want to connect to, right? What's your preferred region? You may do this for many reasons, right? If you think about this information, could be also used in the unlikely event that the service becomes unavailable in the primary region. So the application immediately switches to the next available region, and you get a chance through code specify where that region is. And of course, I said through code, but it's obviously injected to this app when it's deployed, and depending on when the app is deployed, you may have rules to inject different values here, which would be the smart thing to do. Or you can just let the multi-homing APIs do it for you. This if you want to do it manually, because there are some business rules that specify what is the second region, right? Otherwise, just let Cosmos DB handle that for you. Now, let me show you how to replicate your database using the Azure portal. Give me 1 sec. Okay, so I'm gonna go back to my replicate data globally here. Okay, as you can see, this is a little map. By the way, everything I'm doing here on the portal can be done programmatically, obviously, right? I'm just doing it here for effect. But look at all the different zones that I have my app deploy. Right? In this case, I don't have multi-region write enabled. Right? There is one primary write region, and the other are read regions. And I do that, or I did that, not because I cannot just click and hit enable here, because that'll be super easy, but because if I do that, I won't have a chance to show you failover, right? Because in a multi-write environment, there is no concept of failover, right? They're all on, always on. So as soon as one is not available, you keep writing to the other ones. There's no primary or single write copy of the database. So let's see, the way for you to add a new read region will be to just hit here, gets added, Korean Central, and then I hit save. No downtime, just keep that in mind, okay? Let's see, let me switch to failover here so you can see. Actually, I'm gonna remove this. If you want to test how this works, right, you can actually manually failover. You select which is the region that's going to become the new write region. Remember, I don't have multi-write enabled, otherwise it wouldn't make any sense. Let's say I want Brazil to be the new write. I understand what I'm doing, right? I'm going to fail this and hit OK. But I'm not going to do that. And of course, you can do automatic failover too. Enable this, and then you specify what is the priority, right? If the first one failed, which one is the second one that's going to become the right? If that one fails too, the next one only is to become the right copy. Okay, so let me cancel this. Now, let's say your company loves all these features, right? We manage the database for you. You focus on developing cool features for your app, and you've started creating many applications using Cosmos DB as the backend database. Now, suddenly you realize that you want to run analytics on the data, right? And of course, you don't want to disrupt the normal operation of your application. Right, so you need to replicate the data from all these Cosmos DB databases and collections to a different place, maybe a centralized place where you can run complex analytics, right? And normally you'll have a couple of options, right? One is the traditional ETL approach, where data from Cosmos DB is copied to the central repository in batch using Azure Data Factory or Informatica or any of the many ETL tools available. The other option is use an event-driven one, right? Modern microservices applications use this. This is great, right? Where every event, every change is pushed to a queue, and then we take that from the queue and we copy to the centralized repository. Now, both approaches force you to deal with the complexities of having yet another process to manage and monitor, and to be honest, to deal with the issues that may arise when the process fails or stops working properly. Application developers are not known by always thinking about analytics and how the data is going to be used, and we know that. So to help on that process, we created what we call Azure Synapse Link. And by enabling Synapse Link, Cosmos DB will automatically synchronize your data, your Cosmos DB data, NoSQL data, to an inexpensive, high-performance storage account. that allows you to run SQL or Spark analytics on it, right? Think about this. So all this data movement has absolutely no performance impact on your transactional workloads. It's not touching your RUs that you've provisioned for your application. It's all done on the back end. It's all done on semi-real time as fast as we can. With that new copy, you can now generate, I would say, near real-time analytics over your operational data in Cosmos DB at any scale, and you enable all of this with a single click, right? As I showed you in the portal, when I was creating the container, there was a toggle there if I wanted to enable Synapse link or not, or we call it transactional store. And it's the only thing you need to do. Okay. I'm sure that the business intelligence and the data scientist teams will be extremely grateful if you make the data on your application available for them to play around and do all the cool stuff they do without really having to do much work or affect, most importantly, affect the performance of your app. Okay, and just to show you how that works, let me go back to the portal. So this is my container, right? This is my database, sorry. Let me get there. Let's see, I'm going to create a new container here. And remember, you specify the name of database, the container, the partition, take a throughput, and this is the analytical store, right? And right now it's off because it's a total database. If I create a new one, I can specify it. Oh, I need to enable this integration with Synapse Link for this to work. So not exactly accurate. You need to do two different things. One is enable, and the other is click on. And that will automatically copy all the data that we were looking at, all the data on these containers, to this storage account. Now, the format in which the data is copied, even though it's in a storage account, by the way, we're copying adds, updates, and deletes, right? Which, if you think about, if you're building a data lake, sometimes processing deletes, updates is not super straightforward. Now with Delta Lake and other formats is easier, but we do that all for you. We also manage the schema changes, right? Because as you add documents, maybe this is an IoT scenario, and you just added a different type of sensor and it's sending completely different data, or maybe new data points on the payload. Those data points are automatically added to the schema, so the schema changes are managed for you. Okay, so that's how you set it up, and this is how you will use it. For that, I have Synapse environment, and what I'll show you, close this. What I showed you is the different link services that I have, and I have my Azure Cosmos DB here. All right, so this is my retail data. Set that database, and inside the database I will see all the collections that have the Synapse link enabled, right? So I have retail sales, retail data tests, products, store demographics, POS transactions. So what can you do with those? There are two things that you can do, as I mentioned. You can query these data that's non-structured data or semi-structured data that's been copied into this high-performance environment using two approaches. One is using SQL, right? This is the create Cosmos DB script, right? I'm not going to type all of this here, but it gives you a sense of what you can do, right? For example, here I'm pointing to the account. This is the Cosmos DB account. This is the database. It's called retail data, and I'm projecting some of the columns, right? Even doing calculations on top, and I'm going to create a view on top of that. Once that view is created, I can run a query, and this is all T-SQL, right? So if you think about it from an analytics perspective, you have Tableau, Power BI, MicroStrategy, and you want to run queries, very complex analytical queries on top of your NoSQL database. This view can be accessed through a traditional SQL endpoint. Okay, so for your BI tool, it looks like it's connecting to a SQL database, when in reality it's looking at the transactional copy or the analytical copy of your transactional NoSQL Cosmos DB database. So yeah, you use some creating a view and run some basic SQL statements. Of course, this is the Synapse Studio, so you can do more stuff with your data. And that's all well and good, right? But the reality is that we're working with Cosmos, so there is a lot of semi-structured data, right? So let's look at an example that actually deals with that complexity. And you can see I can create views for multiple containers and then join them together. So all the beauty of SQL available. The example I'm looking at is here. So here I'm actually opening one of the documents using OpenJSON and getting the different values out of the document itself. So let me create this view here so you can see the original data. It's called POS transactions. Let's look at the POS transactions data. Right, and it's relatively large, and I'm only bringing the ID and the order items. Okay, so let's look at this as a table. And if you look at order items, it's a document, right? It's an array of documents. Document is a key value, or the value can be a document too. So instead of, I can really not do anything from my BI tool with this if I don't want to parse it there. I can do it here on the view itself using this OpenJSON syntax. So I'm going to create another view that parses that for me. And now I can run a SQL on top of that view and get exactly the columns that I need. Right? Instead of an array of documents, now I get column by column exactly what I needed out of that document database. Okay, so that is how you will use T-SQL to access this Cosmos DB analytical store. The other option, as I mentioned, will be using Spark Notebook. And there are a few notebooks there that represent examples on how you will go about doing that. I'm not going to run them right now, but I just wanted to show you. They are there. If this ever opens. Going 3, 2, 1. Okay, didn't open. Let's go back to the slides. I will coming close to the end now. I'll mention a few additional features, right, that are, I think, pretty cool. Also help developers. The first one is indexing, right? If you think about at a global scale, schema and index management is not trivial. The good news is that Cosmos DB has automatic and synchronous indexing of all the ingested content, right? So there is no need to define schemas or secondary indexes upfront. We do that automatically for you for all the paths, right? This index policy can be changed at any time to accommodate your needs. Okay, so if at any point you decide, well, this is all good, but I don't want to index this specific piece of the document because I will never search for that, and this is just going to waste the space. You can go and modify the index policy and remove that entire path out of it. Okay. The other, I think, the other cool feature is that we provide a persistent record of changes to a container in the order that they occur, right? And this is something we call a change feed. And these persistent changes can be processed asynchronously and incrementally, right? And this output can be distributed across one or more consumers for parallel processing too. This will enable scenarios where, like triggering a notification or a call API every time a document is inserted or modified, stream processing for IoT, right, or performing analytics, or additional data movement by synchronizing with a cache or search engine or a data warehouse, or maybe archiving data to cold storage. Because I didn't mention, but obviously Cosmos DB offers TTLs at the container and at the document level, and the TTL is different for the analytical store and for the transactional store. Right? So on your app, you can keep maybe a few months of data online, and your analytical store, you can keep years of that data. It's less expensive and it's meant for analytics, not for the traditional operation. So let me show you quickly where you will do that, right? This is the sales orders containers. And if I go to settings, I can go to index policy. And by the way, this is a TTL for that. You can override that at the document level. And this is the index policy, right? What paths I want to include, by default, all of it, and which ones I want to exclude. And I'm only excluding the E tag, which is a property that we add when you insert a document. But I could, maybe I want to exclude the, I don't know, the sales order detail ID out of the details, because that's never used. So I could add that path here to the indexing policy and exclude it. Right, I'll just need to modify this and save, and the index will automatically be rebuilt. Okay. So that's one thing. And the other thing I'll mention, I find it interesting. Let me go quickly to a different one. Let me go to a different Cosmos DB here. It's well, it's gonna take me a little bit to get there, but I want to mention that we also have integration with GitHub. So the notebooks I was showing you, or here on the Data Explorer, you see I can run queries, right? I can also write notebooks, and we do have a very good gallery of notebooks to help you get started, right? If, for example, you want to know more about how to write visualizations, or get started with the SQL API, or the Gremlin using graph analytics, maybe indexing and query performance, testing some things, how to write store procedures, because NoSQL in Cosmos DB supports ACID transactions. So we let you write store procedures and triggers using JavaScript. Request units has some examples on how your RUs can be set, examples for IT anomaly detection, etc. But you can connect these to your GitHub repo, and that way the notebooks that are right here are actually stored locally, centralized, different place. And that's all I want to show you here. I'll jump to the deck for the final slides. As you think about Cosmos DB, just to wrap it up, I'll remind you some of the scenarios where Cosmos DB is the ideal database for your solution. Right, the first one is IoT, and here Cosmos DB with this unlimited throughput can easily ingest and auto-index large volumes of semi-structured data while still providing real-time queries, right? Which is super important when you build this type of real-time telemetry applications. The second one is applications that provide personalized experiences, right? Here Cosmos DB has, for example, an Apache Spark connector that allows you to develop ML applications in real time. Right, and the Apache Spark connector is pretty smart. It actually goes directly to where the data is stored. Okay, so it's pretty efficient. And the third one is some critical applications, right, that need to deliver consistent, real-time, always-on user experiences around the world. And again, this is a place where Cosmos DB with its 5 nines of availability is ideal for this type of scenarios. Okay. And the final one, the no-brainer, I guess, if you're running a different NoSQL database and having to deal with, replication, indexing, backups, partitioning, scalability limitations, complex ETL for analytics, I'll invite you to let Cosmos DB take care of those concerns while you and your team focus on developing, building new awesome features for your app. We have 4 different ways for you to start using Cosmos DB for free. Right, strongly recommend using the Cosmos DB free tier. Right, remember you get 1 for each subscription. Okay, of course with certain limitations, but it's free. So go for it. No excuses not to try it. And if you're developing locally, maybe you want to install the Cosmos DB emulator on your Windows machine. Okay, so no Mac or Linux version yet. But if you're flying an airplane or a place without internet, having the emulator running on your local Windows machine is pretty cool. And because learning never ends, make sure to go to Microsoft Learn, where you will find lots of Cosmos DB modules, some of which I recently updated. So enjoy the content there. And with that, I'll close it. If you guys have any questions, this will be the time. Otherwise, thank you very much for your time.
Any questions for Tonio?
Hey, Tony. Yeah, this is Matt Brofhart. So I don't want to derail the conversation, but one of the things that always comes up with Cosmos DB and NoSQL is when to use it and when not to, right? So a lot of the systems that we support, businesses that we support, are 9-to-5 business users, mostly in North America. Mm-hmm. And at what point do you say this is a as a solutions architect designing a system? At what point do you go through your triage of this is a good candidate for Cosmos DB versus SQL Server?
Yep. So I would start with the actual nature of the data itself, right? If we're talking about purely structured data, I'll probably have a hard time considering a NoSQL database for that. If the data is semi-structured in nature, the schema changes all the time, and you're receiving data from a third party probably, or is IoT scenario, then a NoSQL database to go. Otherwise, you're going to be in the constant nightmare of accommodating your relational structure to feed the new data, right? The other thing I'll look, even if the data is perfectly structured, the other thing I will look is for strong SLAs, right? If you need a database that will guarantee a specific number of milliseconds on latency, on throughput, Cosmos DB is the only one that does it, right? If you need that strong guarantee, I wouldn't think it twice. That I would feel comfortable just going after Cosmos DB. If you need a geo-replicated application, right, where doing multi-master is just a checkbox or a toggle, that's another place where I will definitely consider Cosmos, because we manage that for you.
So that comes to the question of, so if I have a use case where I know it's a strong use case for relational model, right? Mm-hmm. But it needs super high availability, geographically distributed, low latency across multiple countries. So you're saying in that scenario, I would be better off trying to architect it in a way that it would leverage Cosmos DB.
That's what I would do, because the way you've described it, I would prefer the service to give me those capabilities as opposed to me trying to architect a solution that offers the same things, right? Again, the greater thing is like buying insurance, because if we don't fulfill those SLAs, we'll pay you for that, right? So as you can imagine, the SLAs that the 10 milliseconds that we put on our website is actually a higher value than the actual, throughput and latency that the service guarantees. That's your respect, right? It's probably the real number is probably close to 6 milliseconds.
Yeah. I mean, that makes sense. But what I've seen a lot of NoSQL purists or NoSQL advocates out there trying to sort of fit the square peg in the round hole on doing NoSQL everything. So it's good to hear your response to that question.
Yep, and you will, good or bad, when you talk to product managers, right? From any company, right? Let's say you talk to a product manager from Microsoft. if you talk to the Azure SQL product manager, Azure SQL can do anything. Right? The same happens with Cosmos. So I think the conversation with architects, I think, is more, maybe more honest, more to the actual problem. There are cases where Cosmos DB is amazingly well, and there are cases where using traditional all Azure SQL works great, right? And we will be enabling Synapse Link, this shadow copy to a regional to a storage for Azure SQL 2 in the near future. So all that ETL is also going to be automated, which is great news from my perspective.
Good to hear. Yeah, that's cool.
Any other questions for Tonio? If not, thank you, Tonio, for the great presentation today.
Thank you, guys.
I'm going to stop the recording, and then for those left, you